Alright, so section 3.6. So we're still finding the derivative, but this time we're going to be using the chain rule to derive. Okay? So in this section, just FYI, we're not going to be covering the parametrized curves. Okay, we'll leave that for Calc BC if you're in it. Anyways, consider this function y equals 2x plus 1 cubed. So usually how would we find the derivative? How would we find dy dx? Okay, so take a second and think about it. Our old method is to multiply out and then use the sum and difference rule, basically the power rule. So what we would do is we would multiply this out, right? Because 2x plus 1 cubed is 2x plus 1 times 2x plus 1 times 2x plus 1. Once you multiply this out, you get 8x cubed plus 12x squared plus 6x plus 1. And now we can find our dy dx by taking the derivative of each part. And that ends up being 24x squared plus 24x plus 6. Done. Okay? Now, this method would normally work just fine, right? But what if you had something like y equals 2x plus 1 to the 9th, and it asks you to derive it? It's going to take a lot of time to FOIL out or multiply out 2x plus 1 9 times. So that's why we have this thing called the chain rule. It's when we have a function inside another function. Okay, so here is our new method. We're basically going to consider y as a composition function. That means a function within a function. So a function within a function. Alright, so let's consider this equation, y equals 2x plus 1 cubed. So basically the idea is if, let's do this, okay? Let's cross out, let's cross out outside and put inside on this box. And let's cross out the inside and put outside on this box. Okay, it's just a computer error. And let's start with this. So here's the idea. The first thing that you're going to do is you're going to identify what is your inside function. And we're going to call that inside function a u. So looking at this, what part of all of this is on the inside? Okay, the thing that's on the inside is the 2x plus 1. And the reason that's on the inside is because that thing is being cubed. So the inside function is 2x plus 1. And now our outside function, using u, we're going to identify it as what's happening to u. If u is 2x plus 1, what's happening to u? It's being cubed. Make sense? So our whole function, if our inside is 2x plus 1, our outside is u cubed. So now that we've identified the inside function and the outside function, all you really have to do is derive. Okay? And I need you guys to do one more thing for me, just computer error. We're going to switch these around. This is going to be du dx. And this is going to be dy du, because this is y equals u cubed, so we're finding the derivative of y with respect to u. And this is u equals 2x plus 1, so we're going to find the derivative of u with respect to x. Okay? So what's the derivative of this right here, of this function? So du dx is just 2. And what's the derivative of this guy? dy of this guy right here? dy du is 3u squared. Alright, so now basically to calculate what dy dx is. Alright, so we have du dx and we have dy du. How are we going to get dy dx? So to get dy dx, we're basically just going to multiply our dy du times du dx. What do you notice happens to the du's? Right? They cancel out. So here, what's my dy du? My dy du is 3u squared times, what's my du dx? Times 2. But there's one thing that we have to remember, that we are finding the derivative of y with respect to x, so we cannot leave this u as a u. We used it for a second just to help us figure out what our derivative is. So basically we just substitute back in. This is going to be 3, and what was our u again? Our u was 2x plus 1 squared times 2. We clean this up, we're going to get 6 6 times 2x plus 1 squared. And if we continue to clean this up, just to make sure, I mean, we can leave this answer just as it is, but just to show you that it's the same exact answer as what we got in the previous problem, I'm going to FOIL this out. So this is going to be 2x plus 1 times 2x plus 1. So this is 6 times 4x squared plus 2x plus 4x plus 1. So this ends up equaling 24x squared plus 24x plus 6. So if you take a look at the previous page, you'll notice that these two answers are the same. Alright, so it looks like it's long, but it's really not once you get used to it. But this is tough if you don't practice. You will easily confuse yourself. So this multiplication technique is called the chain rule. So this is rule number 8, that goes along with the product rule, the quotient rule, and all of those other rules that we talked about. So the chain rule says that if y equals f of u is a differentiable, use a different color, function of u, and u equals g of x is differentiable function of x, then y equals f of g of x, okay, outside function, inside function, is differentiable function of x and the following. So basically the idea is that dy dx is going to be equal to dy du times du dx, right? Or another way we can say it is dy dx is equal to the derivative of the composite function, which is equal to the derivative of the outside guy, so the derivative of the outside with the inside intact times the derivative of the inside. Alright, let's do some examples. So we can basically think the chain rule as the derivative of the outside function times the derivative of the inside function. That's basically all it is. Okay? So here's the idea. We're always going to identify who's on the inside, and we're going to call that inside guy u. So u is x cubed minus 1. Okay? So once we've identified what u is, our outside guy is y equals u to the 9th. And now we're going to take the derivative. So du dx, right? Derivative of u with respect to x. And that's 3x minus nothing, right? Because 1 is a constant. And we're going to take the derivative of y with respect to u, and we're going to call that 9u to the 8th. And now to find our derivative, we're going to multiply these two things together. And because it's multiplication, does it really matter who's first and who's second? It really does not. Okay? So I'm going to multiply these two together. And just out of force of habit, I do this guy first. So it's going to be dy dx is going to be equal to 9u to the 8th times 3x. And then never forget to sub u back in. So this is going to be 9 times, what is our u? X cubed minus 1 to the 8th times 3x. And then just clean it up a little bit. Oh, and I forgot the squared here. Sorry, guys. I did forget the squared there. So that's supposed to be a squared. And then you just clean it up, and the only way you can clean this up is just to multiply these two together. So 9 times 3 is 27x squared times x cubed minus 1 to the 8th. Done. That's my derivative. Okay, here's another example. Now, one thing you guys need to know about trig functions is tan cubed x is the same thing as writing tan of x cubed. The reason why this is important is you can see that we can identify easily what's our inside function. Our inside function is tan of x. And our outside function is y equals u, right, cubed. Take the derivative of both. Okay, this is where you have to remember what the derivative of tan of x is. So du dx is secant squared of x, and dy du is 3u squared. Multiply the two. So dy dx is 3u squared times secant squared of x. Don't forget to sub in. So it's 3 times tan x secant squared x. Can't really simplify this any further. There's my answer. Sorry, guys. Forgot the squared right there. Alright, another one. Alright, this is a good time to kind of, stop the video, see if you can figure it out by yourself. Alright, so who do you think is the inside function here? There is my u. That's the guy on the inside. Because what's happening to him? He is being taken by sine. So our inside, our u, is going to be x squared plus 9. So our outside is y equals sine of u. Take the derivative of both. So du dx is 2x. dy du is cosine of u. Now multiply the two together. So cosine of u times 2x. And don't forget to sub u back in. So it's cosine of x squared plus 9 times 2x. Easy peasy, right? Okay. Another example. I'm sure you guys can see that on your sheet. It's to the negative 2. So who is my inside guy? So my inside guy is right there. Now keep in mind that this problem could have been given in this form right here. X plus x cubed squared. So it could have been given in this form right here. You have to remember that whenever you have a exponent on the bottom, it's going to be in your best interest to rewrite it as a negative exponent. Alright, so our inside guy is u equals x plus x cubed. Our outside guy now is going to be our u raised to the negative 2. We take the derivative of both. So this is going to be 1 plus 3x squared. The derivative of this is going to be negative 2u to the negative 3. So now we multiply the 2 to get our dy dx. So it's negative 2u to the negative 3 times 1 plus 3x squared. I'm going to make sure to put that as a quantity because it is being multiplied by this whole thing. And now I'm going to sub my u back in. Now once you get good at this, you can sub the u directly before you write this step. Okay? But I'm just showing you step by step right now. So negative 2 times our x plus x cubed. That is raised to the negative 3. And all of that is multiplied by 1 plus 3x squared. Now remember, on the exams, we don't like negative exponents, so this part right here, I'm going to rewrite it, and I'm going to send it down to the denominator, and it's going to become cubed. You could simplify this one more step by saying, negative 2 negative 2 minus 6x squared over all of that. But this is fine. Okay? Alright, remember, this problem right here is the same thing as saying sine of x raised to the negative 5. So who's the inside guy? Sine of x. The outside guy is the negative 5. Okay, I'm going to let you guys do this one. Okay. Take a second, do this one really quick on your own, and then play the video to see if you got it correct. All right. Moving on. All right, so who's on the inside? It's that right there. So u is on the inside, so that's pi minus 1 over x. Remember that pi is just a number, okay? And remember that 1 over x can be rewritten as x to the negative 1. The reason why that's important is we do want to find the derivative in a second, so we do want to rewrite that as negative 1. Okay? All right, and then our outside is going to be cotangent of what we now know as u. Okay, let's find the derivative of both. Remember your trig derivatives. So the derivative of pi is just a constant, right? So it's a number. So the derivative is 0. And then the derivative of negative x to the negative 1, you bring down that negative 1. So what happens? You get a positive x raised to the negative 2. And then here, cotangent of u is going to be negative cosecant squared of u. So now my dy dx is just negative cosecant squared of u. What is u? U was pi minus 1 over x times x to the negative 2. I'm just going to right away write that as 1 over x squared. So I'm going to put the x squared down here. Okay, you don't need that multiplication sign right there. All right, so here are some problems that you obviously see that there are two parts. You have this right here where you need to use the chain rule at some point, but you have two of them and they're multiplied. So this is a problem where you're going to start off using the product rule, okay, because they are multiplied, and at some point you're going to have to find the derivative of this using the chain rule. So let's do this. So y prime, first off we're going to use the product rule because these two are being multiplied together. And remember, the product rule is you take the first guy and then you do the derivative of the second guy, and then plus the second guy, and you take the derivative of the first guy. Okay, so here, in order to take this derivative, we actually have to use the chain rule. Now to take this derivative, it's easy. What's the derivative of 1 minus x? Okay, if you said negative 1, very good. So right now, just to write down what we know so far, we know 1 minus x. We know this part stays as it is. We have to do some side work for this, so we still don't know what is going to go in here yet. Plus, this is staying as it is, so 3x squared minus 5 to the 5th. And then the derivative of this is just times negative 1. So we're going to have to do some side work to get the derivative of 3x squared. So let's do our side work right here. So our problem is 3x squared minus 5 to the 5th. Remember your chart. Inside, outside. So what's our inside function? It's 3x squared minus 5. What's our outside function now? It's u to the 5th. Now find the derivatives. So 6x. Find the derivative, 5u to the 4th. So now what's our derivative? It's going to be 5 times u. What was u again? 3x squared minus 5 to the 4th times 6x. If we clean this up really quick, 6x times 5, which is 30x, and then 3x squared minus 5 to the 4th. There's our derivative. And that can go right here. So 30x times 3x squared minus 5 to the 4th. And guess what? That right there is more than enough good work. If you wanted to just, write it a little bit neater, you can do 30x on the outside times 1 minus x times 3x squared minus 5 to the 4th plus, becomes a minus because of that negative 1. 3x squared minus 5 to the 5th. That's just to clean it up a little bit. Okay? Alright, why don't you guys attempt this one on your own? Again, it's something that you have to start off using the product rule because you have two things that are being multiplied together. And then at some point you're going to need to use the chain rule. Alright, this one too, I want you guys to attempt this on your own. Again, remember theta is really x, and you have two things that are being multiplied together. And this guy right here is a function, which is 1 over x, okay, inside another function. So at some point you're going to have to use the chain rule. Alright, that negative 3 is supposed to be up top. So this right here, some fun stuff, right? So this is the inside function, this is the outside function. But you'll notice while you're trying to find the derivative of the inside function, you're going to need to use another rule. Alright, and then this last one right here, you're going to apply the chain rule more than one time. So we're going to apply the chain rule more than one time. So, really quick, I'm going to rewrite this with this squared on the outside because really this is just secant of pi t, right? And then that's squared. So in this problem, you'll notice that we have this inside of this, and then this is inside of that. So if we start off, this is basically how this is going to work. The inside function and the outside function. Right now, who's on the inside? Who's on the most inside is all of this, right? So our u is going to be secant of pi t. And then our outside is going to be our u squared. But to find the derivative of this, to find du dt, right, the derivative of u with respect to t, we're going to actually have to use the chain rule again. So we can't just find the du dt right away because this is a function within another function. So what we're going to have to do is basically identify again who's on the inside and who's on the outside. So on the inside is pi over pi times t, on the outside is secant of u, right, because u is that. And now we're going to find the derivative of pi t. Remember, that's just a number. It's like saying 3t. So what's the derivative of 3t? It's just t. And then what's the derivative of secant of u? Secant u tan u. And let's not forget to find the derivative of this. Alright, so really quick, what was the derivative here? So what is the derivative du dt? It's basically this times this, and don't forget to plug in your u's. And what was our u's? Our final u's was pi t. So it's going to be t times secant of pi t tan of pi t. And what's the derivative of 2u squared? So our dy du is 2u. And now we can find our dy dt. The reason it's not dy dx is because we don't have an x in the problem, we actually have a t. So our dy dt is going to be our dy du times our du dt. So it's going to be 2u. But which u is that? This u comes from that guy right there, right? And that u came from secant of pi t. So that u is going to be secant of pi t times all of this. T times secant of pi t tan of pi t. Now you can just clean this up a little bit by basically putting together the 2 and the t. The secant of pi t's, since everything's being multiplied, you can call secant squared of pi t. And then the last part is times tan of pi t. Alright, I think a 30-minute video is good enough. I would like to give you guys one more extra practice problem for you to do it on your own, and we'll check it together in class. This is another chain rule more than once problem, and it looks like this. So find the derivative of x plus 5 raised to the 5th minus 1, and all of that is raised to the 4th. Alright, good luck, enjoy.